Hello everyone, I am Amulya, Assistant Professor in Department of Electrical and Electronics, Sai Vidya Institute of Technology. In today's session, we are giving a demonstration on electromechanical over voltage relay. This is one of the experiment in relay and high voltage laboratory. So the aim of the experiment is to study the time versus voltage characteristics of an electromechanical over voltage relay. That means here we are going to find the relation between the operating time of the relay with respect to the supply voltage. So how does the time and the voltage both are relating? So this experiment is similar to the previous session experiment, that is electromechanical over current relay. In the over current relay we have done a relation between the time versus current. So here we are doing a relation between time versus voltage, similar to the previous experiment only this is also. So now coming to the circuit diagram. So this is the circuit diagram for the over voltage relay. The supply from the mains we are receiving a 230 that will be fed to the fuse, then it goes to the variac, nothing but the auto transformer for the variation of the voltage. Then it will go to the step up transformer. Why it is step up means, so we are doing a over voltage here, the voltage to be stepped up here. So from the input we are giving a 230 and it will go to the output as stepped up as 400 voltage. So this 400 voltage will be given to the relay coils here. So this is our electromechanical over voltage relay here. And this is the relay auxiliary contact. So this auxiliary connection we are using for the timer. So this timer will going to indicate at what time the relay is being operated. So this is regarding the circuit diagram. So now we are going to see the main experimental arrangement of the electromechanical over voltage. The kit is similar to the over current also. So this is the time multiplier setting, we call it as TMS. This has been connected or attached to the moving arrangement. So this is the moving arrangement of the electromechanical relay, and this is the fixed contact, and these two are the electromagnets. Between these two electromagnets the aluminum disc will be rotated. So this aluminum disc is attached with the calibration scale. So this will be reading the values starting from 0 to 1. So this whole calibration we call it as TMS. So the TMS value is directly proportional to operating of the relay. So this spindle, it should need to come to the relay contact, then it indicates tripping of the relay it is. So now here this is the, we call it as a plug setting multiplier, that is a PSM, or we also call it as a relay operating voltage here. So this values are given from 121 to 187 volts. So what does it indicate means, suppose we set the value of PSM to 121 means the supply voltage should be more than 121. So before less than 121, if they set the voltage means the relay it won't be operating. It is just like a permissible limit for the relay it is. So while taking the reading, if you are connected to 121 means we need to set it to more than 121, the supply voltage should be given. So now coming to the connection of the circuit. So observe here, S1 is connected to one end of the relay coil, and S2 of this transformer is connected to another end of the relay coil, and AC1, that is auxiliary contact, is connected to timer T1, and AC2 should be connected to another end of the timer. So same way we are going to connect it here. S1 is connected to relay coil, S2 is connected to another end of the relay coil, T1 is connected to auxiliary contact, and another end of the auxiliary contact is connected to timer T2. So this is about the connection. So before switching on the main supply, we need to make sure that the toggle switch of the timer, either it should be in set mode or it should be in off mode. It should not be directly in the start mode. And this is the reset button for the timer, and these two are the indicator for the relay switch on, and this is the indication for tripping of the relay test. So now we are going to switch on the supply. Once we switch on, the toggle switch should be in set mode. So coming to the case 1, see, observe here, these are the observations here. So in the case 1, we are going to study the effect of the relay supply voltage versus operating time. So observe here, so here we are taking this TMS value as 1 and PSM will be set to 121. So that means the supply voltage versus operating time we are doing it here. Since the PSM is 121, now same way we are going to arrange here, TMS is 1, PSM is 121. So observe here, the TMS, the timer value, that also should be set to 1 and the plug setting should be set to 121. So these two connections need to be, these two settings needs to be made. Then we need to switch on the supply. So now we are going to switch on the supply. This is in set mode. So we are going to set the voltage. This is the supply voltage variation, nothing but the variac here. Since we have set the PSM as 121 means, so here the supply voltage should be more than 121. Then only the relay will going to operate. So now we are going to set the voltage to 130 volts. Then bring this to off condition so that the aluminum disc will come back to its initial value or initial condition. So after that, then we have to bring the switch to start condition. So once we bring this to start condition, so the relay will start to operate, and it takes a specified time for tripping. So until that we need to wait. So now the relay will going to trip. So what we have to note down. So now the supply voltage is 130 and the relay operating time for 130 is 38.5 seconds. So this is what the case 1 is. Now increasing of 1010 voltage, we need to take 5 readings, 130, 140, 150, like that we have to take 5 readings. So now moving on to case 2. So the case 2 is also similar to case 1, but one thing you need to observe here in the case 1 and case 2, we are keeping the PSM value as a constant, but we are varying the timer values. So in the previous we have kept the timer to 1, and here we are reducing the timer value to 0.5. So that indicates that as we are reducing the timer value, and the operating time also should need to reduce, because the timer TMS and the operating time, that is the tripping time of the relay, these two are directly proportional. So that is what we need to observe. That means in the case 2 we are going to start taking from the same voltage, because PSM is 121 means the supply voltage should be more than 121. So we'll start from 30, then we'll see at what time the relay will going to trip. So it should need to commit as a half of it, because here the TMS is 1, here it has been reduced to 0.5. So the operating time also should need to come half of it. So same thing we are going to observe now. So now we are set the voltage to 130, and here we need to set the reduce the timer value to 0.5. So we set the timer value to 0.5 here, and the PSM should be equal to 121. So after that we need to bring the switch to off condition. Then we need to bring this to start mode now. So the relay start to operate, but one thing you have to remember here, the timer value compared to the previous case, it will be reduced it to half of it, because we reduce the TMS also. So once the relay is tripped, so then we have to note down the operating time here. So now the relay has tripped. So for the supply voltage of 130, we have got the timer as 17.81 seconds. So now observe here from case 1 and case 2. So this has been reduced to half of it for the same supply voltage 130. Here for the case 1 it has taken 38 seconds. Now for the same supply voltage in the case 2, by reducing the TMS to 0.5, it has been getting the operating time as 17.81 seconds. So this is about case 1 and case 2. So from these two cases, we need to plot a graph. So that is by taking the x-axis as a supply voltage and on the y-axis as operating time. So here the graph will be same, but only thing we need to observe, the time, operating time will be reduced to half of it. So these two graphs are just like a IDMT characteristics. IDMT means inverse definite mean time. Minimum the supply voltage, operating time taken for the relay will be maximum. As we keep on increasing the supply voltage, the time taken for relay to trip will be minimum. So this is what we have to observe in the case 1 as well as in the case 2. So now coming to case 3, observe here. So here we are going to study about the effect of a PSM on the operating time. So look at this entire table. In this entire table, we are keeping the timer value as a constant. But in the previous case, observe here, we are keeping the plug setting value as a constant, but we varied the timer value. But in this case 3, we have kept the timer value constant as 1, but we keep on varying the plug setting values. That is, here we kept it as 121, 132 and 143. So by taking these different values of PSM, so we need to note down the supply voltage and the corresponding operating time of the relay need to be taken. Then the average value of the operating time should be noted down. So this is also similar to the previous case only. So from this we are going to get the graph like this way. So that is, on the x-axis we need to take supply voltage, and on the y-axis we need to take average operating time, because we need to take the average value of all the operating time. So from this table we'll get one operating time, that value will be added with this, then it will be added with this. So these three average should be taken here. So one supply voltage versus the average value we need to note. So similarly, this is the table for TMS1. Likewise, we need to take one more table by taking a TMS as 0.8 fixed, and one more table TMS will be fixed to 0.6. So from these three curves we'll be observing that, so minimum the supply voltage, more will be the operating time. As the supply voltage keeps on increases, the timer for operation of the relay also will be reduces. So this is about the electromechanical over voltage relay. Thank you.